In this video, we're going to look at the stylized scattering of bricks in my castle asset. Though we'll focus solely on the bricks, some of the techniques covered are also used in other parts of the asset, specifically rock scattering and dirt accumulation in the corners. To start with, we need to figure out where the clumps of bricks will be, so let's scatter some points on the base shape of the castle using distribute points on faces, set to Poisson disk, and then instantiate some bricks on those points so we can see what's happening. It's worth mentioning that I've linked up some things from the parent graph to the inputs of the group we're in. This is just to keep things tidy so we can focus on the scattering. That said, the overall technique should still be applicable. We're off to a good start, but you'll notice that we have bricks on the top and bottom of the castle, and we just want them on the sides, so we'll have to remove the top and bottom facing polys from the input geometry. In order to do this, we'll use the compare node on vector mode to check the angle of the normals compared to a direction. If it's less than the angle threshold we give it, it returns true. We do this twice, once for weld up and once for weld down. We then combine them using a Boolean math node set to OR. We then feed this into a delete geometry node set to faces, and now our bricks will only appear on the sides. Now that we have the clump locations sorted, let's set up the actual bricks that we'll see. Add another distribute points on faces node, again set to Poisson disk, this time with a smaller distance so that we get a denser amount of bricks. To get the clumping effect, we're going to check the distance of these points from the original clump points. Anything that is greater than a certain distance away will be deleted by a delete geometry node set to points. Let's fix the rotation weirdness by taking the rotation output from the distribute points on faces node and linking it to the rotation input on instance on points. The bricks are poking out a bit too much for my liking, so let's inset them using the set position node's offset function. Take the normal output of the distribute points on faces node and feed that into a vector math node set to scale. Link that node to the offset input on the set position node. Use a negative value on the vector math node to push the bricks further into the wall. To break things up, let's add some random rotation. I'm using a node group I've prepared earlier, but it's fairly simple. Start with a random vector to set our angle range, and then we need to convert this value to radians. There's not currently a vector node for this, so just divide it by the value of a radian. Here I'm multiplying it by 1 divided by a radian, but the result is the same. Feed that into the rotate Euler node, set to Euler and local. Connect that to the rotation input of the instance on points node, and you should see the rotation being nudged a bit per brick. Next, add another random value node set to vector and link that to the scale input of the instances on points node. It's looking a lot better, but I'm not liking the hard edges on the clumps, so let's make that more organic. Start by removing the greater than node, and let's replace this with a map range node. We're going to use this to dictate the probability of whether a point is deleted or not. Change the from, min and max values to something like 2 and 5. This will become the probability fall off. Now link this to a random value node set to Boolean, and then into the delete geometry selection input. We now have a more interesting border of the clumps of bricks. Using another node group I've made earlier, I'm adding some more random rotation. This time I'm using the axis angle mode of the rotate Euler node to rotate the object by an angle multiplied by a random integer. Here I've set the offset angle to 180 degrees, so it's randomly flipping the object around to add a bit of visual interest. Orbiting around, we can see that the bricks overlapping the windows, which looks awful, so let's fix that. We're going to use the geometry proximity node again to check for any points less than a certain distance from the windows. Use this value as a selection for another delete geometry node. Similar to the problem with the windows, the bricks are going too close to the edges of the castle. So let's do the same thing again, this time using the group input for castle edges as a target for geometry proximity, and delete anything that's too close. With all of the logic in place, we can now adjust things to get the look that we're after. Now is also probably a good time to link up all of the controls to the parent group input so that you can pass the file onto your colleagues and they can more easily work with it. And that's it! If you have any questions, feel free to leave a comment below. And if you want to see more of this sort of thing, the best way to let me know is to like and subscribe.